is section 10.1, our first section of chapter 10. We're talking about three-dimensional solids. So in class, you are supposed to read with your group pages 520 to 524 because in this section we're just becoming familiar with the different parts of three-dimensional solids. So go ahead and take some time to read page 520 to 524. I'm going to just highlight what we did in class. In class, each group was assigned one figure. And so before that, we needed to just become familiar with three-dimensional figures. Up here is just some pictures of everyday three-dimensional figures. Some crystals forming what we call many polyhedrons, which would be a polyhedra. Polyhedra is the plural. A polyhedron is simply a three-dimensional figure that encloses a space using polygons. So we're gonna say a polyhedron is a figure with polygons that enclose a space. Enclose a space. So if we break that down, polygons, remember, is a shape that encloses an area. Area is just two-dimensional with straight sides, and it's closed. So here is a square. All of this three-dimensional figure has all polygons, and it encloses a space. Here it has triangles. It encloses a space. They're all polygons. Right here we have all polygons, all straight sides. It encloses a space. That's a polyhedron. They classify polyhedron by the number of sides. So the one weird one would be if there's four, or the number of faces, not number of sides. So the weird named one, if there's four faces, then it's called a tetrahedron. Tetrahedron. If there's five faces, what would your bet be? It would be a pentahedron. So let's break down what I mean by a face. A face is the polygon, that shape. So if I think of it as a side of my polyhedron, here's a face. And then the place where the two faces meet, we'll do that in blue. Right here, that line where the two faces meet, this face and this face, that would be an edge. An edge, or here's another edge where those two faces meet. And then a point where three or more edges meet is a vertex. A vertex is like that point. So now if we go through these, let's see if we can classify some of these. We have to list a couple more, but this first one has 1, 2, 3, 4, 5. So this would be a pentahedron because it has 5 faces. This cube has 6 faces, so it's actually going to be a hexahedron. We'll add that. You can add that to your notes on the top. There's a little blank space. 6 faces is a hexahedron. Hexahedron. Now if we look down here, this I want to point out, this has 1, 2, 3, 4, 5, 6 faces, so does this cube. Notice they're both hexahedrons. One's a pyramid and one's a prism. It doesn't matter if they're not the same shape as long as they have the same number of faces. Here we have 7 faces. Remember, hepta is 7. 7 faces, one's a pyramid, one's a prism. This one has 10 faces and 10 faces. This is a decahedron. So in our in-class activity, each group was asked to draw and make a poster of one of these figures. And I'm going to have you look at the posters around the classroom and fill these in and add them to your dictionary, but I want to highlight a couple. So first, rectangular prism. When you're drawing this, I always draw a slightly slanted rectangular prism because it's easier to draw at the 3 dimensions. And then I bring down my 4 sides. Now keep in mind that this 4th one is going to be not seen, so I'm going to do a dashed line. And then I connect my sides. My bases are parallel, so those 2 lines are parallel. Same with this space and this line, this side, that's also parallel. Again, I'm dotting those lines that I can't see. So here's my rectangular prism. Remember, if it's a prism, it has 2 congruent bases and they're parallel. Congruent and parallel bases. So if I look at this part, they say label the 2 bases. We're going to say that this top and this bottom, in this case, are my bases. They don't always have to be the top and bottom. I could rotate this and they could be on the side, as long as it's the 2 parallel sides. Then a lateral edge. Lateral means side, so we're going to say that one of those edges where the 2 faces meet, here is a lateral edge. And then a lateral face, we could choose a variety. We'll say this one is a lateral face. The lateral faces are any of the non-bases. So here's a lateral face. I'm just going to highlight that in pink. There's a lateral face, that entire rectangle. The other side's a lateral face, so is this face. And then the height. The height is the same as the lateral edge in this case because it's a right prism. So this is a height. Now what happens if it's oblique? An oblique rectangular prism just means that it's leaning. So if I were to redraw this, here's my rectangle. This time my sides are going to be leaning. This is a poor angle choice. Again, these should be dotted, so we'll dot those because they are not seen. Now this is not the most perfect of drawings, but I want you to get the idea that an oblique rectangular prism is a leaning prism. So again, my 2 bases are going to be that top and the bottom, so we'll just label that base because those are the 2 congruent and parallel parts. And then the lateral edge, still going to be here. I'll highlight that. The lateral face we'll do in yellow. Still any of those side faces that are the non-bases, so how about this one? It could also be that other side. And then the height, this is where it's different. The height is actually the altitude. So we're going to do orange. The height is that perpendicular height to the ground. So this is the height. So that's the main difference between a rectangular prism and an oblique rectangular prism. So again, same with triangular and prism and an oblique prism. This triangular prism, remember, prisms are named based on their bases. So here are my bases, the 2 congruent and parallel sides. Here's my lateral edge. Here's my lateral face. And then my height this is still my height, my lateral edge. But on an oblique prism, here's my lateral edge, but my lateral height is the altitude. It's always the perpendicular. So moving on, if we have a square, I want to talk about just a little bit about pyramids. If we have a square pyramid, again, they name it based on their base. Here's my square. They always meet at a vertex. I didn't have you label that, so I want to point that out. Here's the vertex, and then you just draw your lines from each vertex to the vertex to connect. Now, again, the lateral edges still where the lateral faces meet. So here's a lateral edge, and then the lateral face would be like one of these triangles. Here's a lateral face, this entire triangle. And the height comes right through that center of that pyramid. So here's the height. It goes goes directly through the center, meeting perpendicular with that ground. Then they ask you to draw a right cylinder, so a right cylinder, just like our soup labels. Here, if you draw a circle, draw 2 parallel lines, and then draw your other circle parallel and below it with a dashed line behind. You'll have your cylinder. Now keep in mind, our radius is always the radius of the circle. A new one, the axis, which is the same as the altitude. If you think of how the Earth revolves around or rotates around the axis, or if you're a car person, the axle of a car, the wheels rotate around the axis or the axle. That's the same thing here. This is the axis, and that is the same as the altitude or the height. So that's the axis. That's what it can spin around on. And the 2 bases, still top and bottom. Doesn't always have to be the top and bottom. This could be my 2 bases if I have a cylinder this way. And I would probably want to make this part dashed. So here would be my 2 bases, the 2 parallel and congruent parts. So here's a base, my circle, and here's my base. If it was oblique, I would just make it slanted. So draw my lines. There would be my oblique, and this time my axis is still through here. But my height would be, this would be my height. Height. So last few, a right cone. A cone's like an ice cream cone. Again, draw a circle. Draw the vertex just like you're drawing a pyramid. Here's my vertex. And then this is my altitude right here. This line is my altitude because it's perpendicular. Now if it's an oblique cone, here is my altitude. I have to draw it down perpendicular to the base. Then finally we've got a sphere. Sphere is like a ball. And it always has a center right in that middle, and the radius. If you were to draw what we call the great sphere, it's like the belt of the sphere. That center is on that same plane, and the radius goes out to the sphere. Now the radius can go anywhere out to the outer parts of the sphere. These are all radii. And then finally, hemisphere. Hemisphere means half a sphere. So, and I mentioned a great circle above. That great circle is that belt around the sphere. The great circle is really the base of a hemisphere. So here is my great circle. And that's going to be the circle with the largest diameter, the diameter that goes through the center of the sphere. Then finally, with your groups, once you were done, you were supposed to complete number 1 through 15. We're going to quickly go through these. I want you to pause this, try to answer them, then check your answers. So the cylinder is oblique or right. It's slanted, so it is oblique. And it has a different height, you can see, than on the axis. OP, that's right here, is the axis of the cylinder. TR is the height of the cylinder. Circle O and P are the bases of the cylinder, the parallel and congruent parts. PQ is the radius of the cylinder. And then we're going on to the cone. The cone is a right cone. The name of the base of the cone, we name it circle C. It's named off of the center of the circle. The vertex of the cone is point A. Here's my vertex. The name of the altitude of the cone would be AC. We do our segment marking above it. The name of the radius of the cone is BC. And then we move on to the prism. The prism, we name a prism based on its base. The base is a pentagon, so it's a pentagonal prism. Name the bases of the prism. So we just got to go around counterclockwise or clockwise, it doesn't matter as long as it's in the same order of the bases. So we've got D, C, B, A, E, and we'll start with I, H, G, F, J. Name all the lateral edges of the prism. That's all of these. So we're going to say C, H, B, G, A, F, E, J, and D, I. Then name an altitude of the prism. Since it's a right prism, we can choose any of the lateral edges, so we'll say BG. And finally, draw an oblique trapezoidal pyramid. So when we draw a pyramid, we just have to draw the base, so trapezoid has one set of parallel sides. And then we can just make a vertex, and it says oblique, so we want it not to be a right trapezoid. So we'll make the vertex, and then we will connect each vertex to that point, the main vertex. All right, so that concludes our lesson. You can now do the homework assignment, page 524, number 2 through 22, and then 24 and 26.